So in this video, I'm going to go through 3.6, which is multiplying matrices. So the key here is that the dimensions, we need to figure out the dimensions of each matrix and determine whether it is defined, so whether the product is possible. Okay, so in order for it to be possible, if we have a row and column, and then we want to multiply times another matrix that is row by column, then these two numbers must be equal for this to be possible. And if it's possible, then the outside numbers will be the dimensions of the resulting matrix. So if we check that, this one has 1, 2, 3 rows and 1, 2 columns. And B, matrix B, has 1 row and 3 columns. So are these numbers the same? No. So this is not possible. That's all you have to write if it's not possible. Now, if it's possible, so then we would have to give the dimensions of the product, AB. So this one has 2 rows and 1, 2, 3 columns. This one has 1, 2, 3 rows and 1, 2, 3 columns. That one's easy to not mess up because the rows and columns are the same number. But we always start with the rows, which are left and right. Now, since these two numbers are the same, the dimensions of the product will be given by the outside. So dimensions of the product, A times B, are 2 by 3. Okay, and that's all I have to do for the first two. Now, 3, 4, 5, we have to actually find the product. If it's not defined, we have to state the reason, which will be that these two numbers aren't the same. So this one it has just 1 row and 2 columns, and this one has the opposite. It has 2 rows and 1 column. So this will be possible because the inside numbers are the same, and the resulting matrix will be a 1 by 1, which is just one entry. So the way we find that one entry is we do 3 times 1 plus 2 times 4. So 3 times 1 plus 2 times 4. So that's 3 plus 8, which is 11. So our resulting matrix is this kind of boring, just one number matrix. Okay, now if we have, these are both square matrices, 2 by 2. So this should be the kind of the easiest case. We've got the inside numbers are the same, so the dimensions are going to be the same. So my resulting matrix is going to be a 2 by 2. So it's going to have one entry there, one there, one there, and one there. And so the way we do this is we take the first row and look at the first column and do the same thing we just did with this one, row and column. So this first entry right here is going to be 1 times 2, because of this 1 and this 2, plus -1 times 1, -1 times 1. Okay, and so then this answer goes right here. That's going to be 2 plus -1. 2 plus -1 is -1. So that's our first entry. Now the second entry is considered this one. And we keep the same row, but now we look at the second column. So instead of this first column, we still use the first row, but now we're going to do the second column. So we get, for this one, we get 1 times -2 plus -1 times 2. And this answer goes here. So that's going to be -2 plus -2, which is -4. Okay, now we move on to the second row. So now we do the second row times the first column, and that goes here. Okay, so we have 2 times 2 plus 1 times 1. So 4 plus 1 is 5. That goes here. Okay, and now we're going to move on to the second column, second row, and second column. 2 times negative 2 plus 1 times 2. So that's negative 4 plus 2. Negative 4 plus 2 is negative 2. So there's our resulting matrix. Okay. And if you want to show, like if you don't necessarily have to show these calculations, you can just write down the answer. Okay, number 5 is I'll have you do, that's the first one I'll have you do for homework. Homework number 5. Also homework number 6. Okay, and let's have you do homework number 7 too. Okay. So now I'm going to do number 8. See, this is a 2 by 1, and this is a 2 by 3. Can we multiply these together? No, because these are not the same. So this is not possible. But what about this one? This is a 1, 2. This is a 1 by 4, and this is a 4 by 1. So we can multiply these together. We should get a 1 by 1 result. And I'll let you do this one for homework. Okay, now these are all the same. Let's go ahead and we can skip these. And let's see what's going on here. Using the given matrices, evaluate the expression. So this negative 2bc means use this b and this c. So you're going to have to do negative 2, and then b is 1, 0, 3, negative 2, and then c is 3, negative 2, negative 1, 4. So you could do this scalar multiple times the first one and just get that out of the way. So that becomes negative 2, because negative 2 times 1, and then negative 2 times 0 is 0. And then negative 2 times 3 is negative 6, and negative 2 times negative 2 is 4. Remember, if there's a number in front, we multiply by everything, but just on one of them. Okay, then we multiply these two matrices together. Okay, and this is a 2 by 2 again. So I'll do this one for you. We should get another 2 by 2. So we take the first row times the first column. So negative 2 times 3 plus 0 times negative 1, which is negative 6 plus 0. Then we stay with the first row and we do the second column. That goes in here. So negative 2 times negative 2 plus 0 times 4. And that's just going to be 4. This is 4 plus 0. Then we move on to the second row and go back to the first column. So negative 6 times 3 plus 4 times negative 1. We get negative 18 plus negative 4, so that's negative 22. And then we do the second row times the second column. So negative 6 times negative 2 plus 4 times 4. So that's 12 plus 16 is 28. Okay, now I want you to do 13 and 14 for homework. Those are subtraction and addition. But this means first you have to do AC, which means you have to multiply AC first. And then you have to multiply A times B, and then find the difference. Okay, and same with this one. You have to do BA first, the product, because order of operations, it's like there's secret parentheses here. Find the product first of both of these individual, and then the addition comes last. Okay, so and then we can skip this one. So your homework, 13, 14, number 9, 7, 6, and 5. So I can write this at the top, 5 through 7. homework is 5 through 7, 5, 6, 7. Number 9, just to recap, and 13 and 14. And I want you to upload photos of your work onto Google Classroom.